So after discussing the features, now we will describe these features one by one here. That is, the first one is the Harvard architecture. In the Harvard architecture, we find here this is the DSP processor, and in this DSP processor, the first is the Harvard architecture. In Harvard architecture, there are the different memories for the program as well as the data here. That is the cache memory for the data, and this is the cache memory for the program at the L1 level, and this is the direct mapped 4 kilobyte, and this is the 2 base set associative 4 kilobyte memory here. At the level 2, there are the two sections. One is the 192 and the 64 kilobyte. That is the total 256 kilobyte at the level 2. So there are the two levels, and at the level 1 there are the two separate memories for the instruction at the program, and the second one is for the data. And like level 2, that's why due to these features it is known as the Harvard architecture. And here there is a separate level here, that's why this is known as the modified Harvard architecture, that is named as the Super Harvard architecture also. Now the next feature is the single cycle, how this DSP processor executes the MAC operation here. See, this is the MAC operation, that is the MAC algorithm is described by this mathematical representation. Multiply here, this is coefficient multiplied by the signal, and then it is whatever is the product that is the accumulated in the previous result, that is the multiply and the accumulate operation, and it is executed into one cycle here. See here, in one cycle how it is executed, whatever is the here the coefficient that is multiplied by the this signal here, then after multiplication result is stored, that is the product is added to the previous result here, and then by shifting it is stored in the result, and then again by shifting it is here utilized for the purpose of the addition into the next partial product here. For that purpose, here we use this type of the architecture here, having the pipelining and the parallel processing, having the 8 functional units, so that these all instructions, if we execute this one, then there will be the 6 steps. It means 6 cycles are required, but by this feature we can execute this one having one cycle here. That is, there is the hardware having the MAC operation into one cycle here. Now in this one we will describe the parallelism. There are the two types of the parallelism. One is the data level and the second one is the instruction level here. See, this is the parallelism at the data level here, that is known as the single instruction multiple data. Means here if the instruction is given, then the same instruction will execute the different processing unit here, and means single instruction, and we will get means different data will be executed by the single instruction here, single instruction multiple data here, and very long instruction word. That is, in this one, as we have discussed in the architecture of the DSP processor, there are the 8 functional units. So what will happen if we have to execute the 8 function here as shown in this figure here, then the different functional units will execute the instruction for the different functions which has to be executed here. So this is the parallelism at the instruction level, and this is the parallelism at the data level here, and it describes the parallel processing, and that is done naturally with the help of the architecture of the DSP processor here. Now pipelining is used in order to enhance the speed. How the pipelining is utilized here? There are the 3 operations. One is the fetch, the second one is the decode, and third one is the execute. Now the fetch is operated by here the 4 phases. First is the program address generate, second is the program address send, and the third one program ready wait, and the fourth is the program receive here. And in the second one, that is the decode, has the 2 phases. One is the dispatch and the second one is the decode. Here by abbreviating we have written then here the PG, PS, PW, PR, DP, DC respectively here, and execute for the purpose of the execution. As we have discussed, there are the 8 functional units, and here there will be the 10 phases here in the especially in the TMS 320C67. Otherwise, in the family of the 6000, there are the 6 to 10 execute phases, but especially in the 6713 there are the 10 phases here. Now see here the next one is the zero overhead looping here, that is due to the hardware that supports for the loops, no branching, no loop overhead, no need for the loop unrolling, and pipelining stalls is also absent here. Hardware circular addressing, as we know in the case of the algorithm of the DSP, there is a repetition of the same algorithm, that is for any particular value of the n. It is executed from m is equal to 0 to m minus 1, and then the same is repeated, means there is circular addressing is required, and this feature is available with the DSP processor here. Now in order to here avoid the burden of the processor, there is a EDMA, enhanced direct memory SS, having the 16 channel, and this controller has the 16 channel. One is the external memory interface having the 32-bit connection, SPI host port interface, MC-ASP multiple channel audio serial port, and this is the multiple channel buffer serial port. There are the 2 channels respectively here for the MC-ASP and MC-VSP. I2C, that is the inter-integrated circuit having the 2 channels, timer have the 2 channels, general purpose input output, interrupt selector along with the power down logic and the board configuration facilities here. Now if we see here the pipelining, as we have discussed in the previous slide here, that the 3 level of the execution takes 3 sections are there in the in order to execute the instruction. One is the fetch, decode and execute. Fetch has the 4 phases, that is the program address generate, program address fetch, send, program access ready wait, and then program fetch packet received here, and after receiving decoding starts here, and before decoding, that is the instruction dispatch. Instruction dispatch means whatever is the packet that is splitted, and then it is sent to the different functional unit, but before that the decoding takes place. Decoding means here decoding of the source register, decoding of the destination register, and decoding of the data path, that is the data path A or the data path B, and data path A is connected to the 4 functional unit, as well as the data path B is also connected to the 4 functional unit, and each path has the 16 registers having the 32-bit width, and there are the 10 execute phases here, that is the A1 to E10 here. Now see how the pipelining takes place here. If we are interested in order to execute this instruction here, naturally 10 cycles are required, but if the here first instruction comes and after one delay the next one, and if this type of the delay arrangement is made, that is delay means here that we are introducing here the energy storing delay elements here, then what will happen due to this programming concept? Now all the phases means starting from the program generate to program send, wait, receive, data packet here dispatch, decode, E1 to E10, all will be executed in one cycle. Otherwise there are the 16 cycles are required in order to execute this one. So this is the advantage of the pipelining here, and if all the phases are executed in one cycle, then it is named as the fully pipelined architecture or the fully pipelined program here. Now the cache memory is available here. As we know, in the case of the DSP processor, there are the 2 cache memory separate for the cache over here, the program as well as the data here. Now see here, due to this feature, we can say that due to the here the cache memory, what happens in this one, we will find that there is a low burden on the processor, and so naturally if the burden is reduced, then what will happen, the speed of the algorithm will be enhanced here. So we are, as we are discussing here, now see here, this is the these are the two cache memories. One is the cache memory for the program and the second one is the cache memory for the data here. And due to these cache memory, what happens? The burden of the processor reduces and the processing speed is enhanced. Now, these are the all features which we have discussed about the DSP processor. So we have discussed how the algorithm is designed, how it is enhanced, how it is converted into the implementable form, and then we have discussed the features of the digital signal processor, that is the target on which it will be downloaded here. So in the next lecture we will discuss about the what are the application of the digital signal processor, means how these digital signal processor will be utilized for different purposes like the audio signal processing or the speech processing, image processing, etc. So thank you very much.